2, 1, and you're live.
Welcome back, folks, to another great episode of Dr. J Radio Live. Of course, I'm your host, Dr. J, broadcasting from the City of Angels. But it's not so much angelic these days. I really like to prefer to say City of Demons. And we are internationally syndicated. And what do you know, speaking of what we were just saying with the guests right before we went on air, and as you see from the title, I put theoretical physics, not to mention the fact that our guest is omnologist. But we were just talking about politics because he is so versatile, and I see this little quote or comment I got from someone here who likes the fact that I'm talking about Trump and Roger Stone, and I just think it's people, you guys are literally on the same wavelength. Anyhow, I mentioned we are internationally syndicated, starting with our home base, UPRN, United Public Radio Network. That is 107.7 FM, New Orleans, Louisiana, plus a hell of a ton of affiliate stations in Canada, in Central and South America, Hong Kong, EU, UK, and speaking of one of the affiliates that followed me from a few other stations over the years to UPRN is also Deprogrammed Radio in the United Kingdom with their terrestrial affiliates in London, Leeds, and elsewhere. They're a big market for the EU and the UK combined. Now, today's guest, although what you see already is just theoretical physicist and omnologist, is so fascinating. He has so many different facets to him. This is going to be such a great show. And I encourage you people that are already in the chat, and I want to give a shout out to YouTube Nation and also iHeartMedia for carrying his show. By all means, people, those of you that are in the chat that I said, hey, the guest is open for questions, just like our guest yesterday, my Lieutenant Colonel Dr. Michael Aquino was. So when it comes time, folks, bring it on. Now, I figured I've given you enough time to check social media, check out the website, drjradiolive.com, and everywhere else to see who our guest is. Well, you've had enough time at this point, so let me just go ahead and introduce him, because I would like to speak, even though I asked him with the one title, if I was to choose, it would be omnologist, is what he said. There's just so many more, and I'm going to let him tell you that. So without further ado, welcome Howard Bloom to the show. Howard, welcome to the show.
Thanks, Dr. J. It's a pleasure to be here.
The pleasure is absolutely on my side, and I can't tell you how thrilled I've been and am working with you on this show. And if you recall, what I was telling you is when I dialed your office number off my mobile, your number was already saved, which means that at some point in 2015 or 2016, around that era, I was already in talks to have you on. I had a 20-month break from early 2017 till 2018, technically at the end of 2016. So that's why I know it couldn't have been then. And so this is just fantastic, because this shows that we were made for this to happen. Now, I'm going to take you back to when you were 10 years old. And if it's too private to talk about the year you were 10, then don't mention it. But what happened at age 10 that started you on this path of greatness?
Well, I have no privacy whatsoever, so the year was, let me figure it out, 1953. I was 10. I was the most rejected child in my hometown, Buffalo, New York. Other kids wanted to have nothing to do with me, and my parents had no time for me. They were too busy building a life after World War II. And all of a sudden, one day, sitting in our living room, a book appeared in my lap. Now, you know books. When you're a little kid, every book on the shelf, you know its location. This is a book that had no location on any shelf, so God knows where it came from. And I opened the pages, and it said the first two rules of science are these: the truth at any price, including the price of your life. And it gave the example of Galileo, and it told the story all wrong. Instead of saying that Galileo cut a deal with the Pope and was under house arrest for 10 years so he didn't have to be burned at the stake, it gave the impression that Galileo had the courage to stick to his truths, even though he endangered himself with being burned at the stake. That wasn't true. But the mythical version, that he was willing to die for the truth, I needed that at the age of 10. And the second rule of science was, look at things right under your nose as if you've never seen them before, and then proceed from there. Look at things look for the things that are invisible to everybody around you and try to yank them out of invisibility and see them clearly. And the example it gave was Anton von Leeuwenhoek, who was the guy who invented the microscope. So two guys who'd been dead for 300 years had reached across that gap of 300 years and saved me, because they gave me a place to be, and that was science. Now, every group I'd ever attempted to get anywhere near had rejected me, but these guys, Van Leeuwenhoek and Galileo, couldn't reject me for a very simple reason. They were dead.
Galileo was the one who invented the telescope, right?
Galileo, yes, it was invented by a guy named Hans Lippershey in Holland, who invented a long tube with lenses at both ends, because Holland was under attack from Spain, and the Spanish Empire. It had been part of the Spanish Empire. It was trying to rebel and get its freedom. And if you could use a spyglass, which is what Lippershey invented, to see the enemy coming over the horizon before the enemy knew that you could see him, it was a tremendous military edge. And Galileo was in charge of weaponry and coming up with next technology weapons in the towns in which he lived, in several towns, in the towns in which he lived. So he basically retro-engineered Lippershey's thing and made it a little bit more powerful. And his invention was not the invention of the telescope itself. It was the invention of where you turned the telescope. Lippershey and the Dutch were using the telescope to look out over the horizon. They were looking horizontally. Now, everybody knew what was in the heavens. There was no point in looking at them, because that was God's living room carpet. Everything up there, Aristotle had told us, was perfect circles, and that's all you'd see, and perfect celestial spheres. That's all you could possibly see. And to turn the telescope up was to look under God's very underwear. But Galileo had the audacity to turn the telescope up, and he invented astronomy in the process. Anton von Leeuwenhoek was a draper in Holland, and he used the same high-tech device, a lens, actually, which had been around for about 400 years, and he used that device to check the weave of the fabrics that he was bringing in from all over the world. India was one of the major sources of fabric for silk. It was China. And he had the idea, not so much of inventing a microscope, it was using a lens and grinding it slightly differently, so that instead of looking horizontally at the weave of his fabrics, he could look down. And he started to look at pond water, and he discovered in it what he called animalcules, tiny little animals in an invisible world we had never seen before. We had never seen it before.
Single-cell animals like algae, or not algae,
but planaria and all kinds of single-celled animal with cilia, with little whips that they use for propulsion. They were rocketing themselves back and forth around the water. He was amazed. There was a whole world we'd never seen. When Galileo looked up at the heavens, there was a whole other world we hadn't seen, and it was a world of rocks. It wasn't perfect circles. It was very imperfect rocks, including the moon, whose imperfections are clear to the naked eye, but we have been ignoring them for roughly 1,600 years at that point.
Howard, you made a really good point, is that mainstream science has always told us that the moon is a perfect sphere, and I want to get your opinion on why they are perpetuating that and what the shape really is. Is it elliptical?
Well, I don't know. I'm not an expert in the shape of the moon by any stretch of the imagination. The Earth is a little weird in its shape. It's not totally spherical. It's a little squashy. But look how planets and moons form. Once upon a time, 300,000 years after the Big Bang, atoms suddenly came into being. Now, they didn't come into being from nothing. There had been this plasma. It was like a bump-em car ricochet of particles, and the major particles were protons, neutrons, and electrons. And they were hitting each other with the speed of two bullets crashing head-on and then bouncing off of other bullets crashing at the same speed head-on. That had been going on for the first 300,000 years. And suddenly, things cooled down. Not so suddenly, but things did cool down. Cooling down means that particles slow down. Now, if you and I had been sitting at a cafe table at the beginning of the universe, and we're now 300,000 years into the universe's existence, and you're the visionary, and I'm the crusty old fart. And you say, Howard, you see those particles that have been smashing and bashing into each other all this time? I predict that they're about to slow down, and see those little particles that are relatively speaking the size of your fist, and see those big particles that are relatively speaking the size of the Empire State Building? I have a prediction, you say, being the visionary. I predict that once these particles slow down and start bashing each other all the time, they're going to discover that they have an inanimate longing. And I would say, Dr. J, you're crazy. You're doing anthropomorphism. There's no way that particles are going to develop an inanimate longing. And then you say, and I have a bigger prediction, the tiny particles the size of your fist, relatively speaking, and the ones the size of the Empire State Building, relatively speaking, are going to discover that their longings match each other perfectly, and they are going to marry each other. And I've got to say, look, Dr. John, let's be serious here. That can't possibly happen. Look how different these particles are. And an inanimate longing, as I said, is anthropomorphism. It's a scientific sin. And whammo. Seconds later, the little tiny particles discover that they have an inanimate longing that fits perfectly with the big particles. And the little particles are electrons, the big particles are protons, and the result is the very first atoms. And once the very first atoms form, they discover another hidden social cue. And the social cue is that they are attracted to each other with a whisper-thin force that has never manifested itself before in the history of the cosmos. And that whisper-thin force is gravity. And over the course of the next 500 million years or less, the sweepings of atoms gather together. And they gather together in giant clouds, immense clouds with a spiral shape. And then they gather within those clouds into superballs, into gravity balls. And some of those gravity balls become so big that they begin to chew apart the atomic nuclei of their heart, and they bleed the screams of dying atoms. And those screams are photons, light. Those things are stars. Gravity balls. Gravity balls are all over the place. Some of those gravity balls manage to be stars. Some of them only manage to be planets. Some of them only manage to be moons. But how in the world do they come into existence? They are in a competition to see which gravity ball can face down the most smaller gravity balls and swallow them whole and bulk itself up, and then go into competitions with other lesser gravity balls. So since a planet is an accretion of smaller gravity balls, a planet is bound to be just a little bit lumpy. The force of gravity on a planet is enough to smooth it out to a certain extent, but there is a certain lumpiness. And why there's a slight aberration in shape is something that's been contemplated all the way back to Immanuel Kant 300 years ago, who contemplated this problem. So don't expect perfection in a nature that works by gang warfare, which is what this is. The biggest gravity ball wins and swallows the smaller one, and makes its larger wholes from smaller entities.
The biggest gravity ball in our solar system that's not the sun, or as others refer to it as Sol, is Jupiter. With this reasoning, would you say that it's possible for the gravity of Jupiter to suck in these other gravity balls, also known as planets, and sort of destroy them?
Well, it wouldn't suck in the other planets because, look, the universe is profoundly social. From the very first microsecond of its existence, the very first particles, the very first things call out to each other with messages. And those messages are what we call attraction and repulsion. And they gather in groups of three. And then this astonishing, unpredictable property comes out of these threesomes. It's threesomes of quarks. Just quarks in, quarks out, garbage in, garbage out. All we're going to get with three quarks is a bunch of quarkdom, 3 times as much quarkdom. No, all of a sudden these radically unexpected properties emerge, and those are the properties of protons and neutrons. And so there is this attractive force all over the place, and there's also, from the very get-go, or from at least 300,000 years into the universe's existence, we have dominance hierarchies. Dominance hierarchies, haven't we been told that dominance hierarchies are the result of patriarchal societies and post-agricultural societies? No, bozo. It goes all the way back to 300,000 ABB, 300,000 years after the Big Bang, when the first atoms formed. Why? Because remember those things the size, relatively speaking, of Empire State Buildings, the protons, and those tiny little things that just happen to have a need that fit those protons perfectly, the electrons? Well, the protons got all the mass. That means the proton decides where we're going to go next, and the electron is a passenger. That gives the proton the dominant position, and it gives the electron a submissive position. Well, social compacts of that kind have been worked out all over the cosmos. A gravity ball, a planet, is a gravity ball that managed, through God knows what means, to work out a compromise with the gravity ball at the very center of things. And the compromise is, I will stay a certain distance from you and rotate around you, and you won't grab hold of me with your gravity. Your gravity will keep me circling around you, but we'll live with this compromise. So the planets are sufficiently separated in their orbits, in these social compromises, that they are not going to collide with each other, and they are not going to swallow each other whole. But there are planetesimals. That's what astronomers call them. There are lesser gravity balls, and you've seen some of the pictures of the ones we've just seen in the cosmos. One is like a figure eight or the shape of a B, except it's squashed and flat. And all of these things are gravity balls with insufficient gravity to make them spherical. And these planetesimals are way out in the Oort cloud, or way out in the space of the solar system. But they have erratic orbits, and they can be swallowed. So the existing gravity balls do get larger from time to time. They are hit by asteroids. Now, you can regard that asteroid hit as a savage attack, or you can regard it as the moon successfully accumulating more planetesimals and bulking itself up. And it's really the capture of these things that has been the basis for the formation of things like stars, planets, and solar systems.
There's a comment here, and I figured best to bring it up to you. This is said by Russell Grant. He says, the moon is hollow and rings like a bell. Also, the sound is good. I don't know if you meant good or not. What do you say about the moon being hollow and rings like a bell?
Well, I've never heard this. Doesn't mean that I'm an expert on this. I'm not. I strongly suspect that the moon is not hollow, because I've never seen it in any scientific study whatsoever. In fact, since I run a space group, Buzz Aldrin conned me in, Buzz Aldrin, the second astronaut on the moon,
yes,
conned me into forming a space group roughly 13 years ago. It's called the Space Development Steering Committee. And and I'm also on the board of governors of the National Space Society. So I see an awful lot of news on this kind of stuff. And there are caves on the moon. In fact, I worked out at Caltech. I was part of two major seminars on how to get down into those caves with rovers and how to transmit energy down to the rovers so they can keep operating in these caves. But hollow, I strongly suspect not. However, music in the cosmos, it was Pythagoras, about 400 BC, who was walking past a metal shop where the guy with the hammer was working on creating a metal plate, and Pythagoras was stunned because to him, what the sound of the hammer on that metal plate sounded musical. And Pythagoras worked out a way of finding what ratios make what musical notes. In one story, Pythagoras hung a weight from a catgut of, let's say, 1 inch, and then he hung another catgut of 8 inches with a weight on the bottom, and another one of 12 inches, and a bunch of stuff like that. And he discovered that these differences make notes, and the notes can make harmonies. So, and he immediately applied the mathematical ratio he derived between the harmonies to the spheres. He felt that he could use those harmonies to detect the distance between the planets. And that idea stayed alive so long that 2,000 years later, in Europe, Johannes Kepler, was still fixated with the idea of determining the distance between the planets by using the ratios of musical notes. But that's not all. I mean, that was the beginning of relating music to astronomy. Recently, within the last 20 years, it's been discovered that in the early phases of the cosmos, Remember I was talking about that plasma where it was just a bumper car ride and everybody was bashing and smashing into each other constantly? And despite that, there was a degree of massive social cooperation. And the massive social cooperation involved particles coming together on a scale in which they came together all at the same time, all across the face of the cosmos, then relaxing and moving apart again, then coming together again, then moving apart, from one end of the cosmos to the other. And the result was pressure waves, waves that moved across the face of this nascent, this new cosmos, this newborn cosmos. And those waves were musical. And the astronomers who discovered them said that the universe at 300,000 or 250,000 years after the Big Bang, 250,000 ABB, that the universe was ringing like a gong. So there is a relationship between music and the cosmos.
Do you think that this is just natural, or do you think that non-terrestrial beings are having these sounds that sound like as if they are music, not just random sounds from pulsars and quasars and even just the planets? I know when SETI or other telescopes, or SETI using telescopes that are pointed to other planets looking for signals, in whether it be the Kepler or the Hubble, even just going to Mars and Neptune and Jupiter, the sounds that come are so differently. And I know they give you the explanations of why, but obviously there are so many sounds that are natural within our universe, within our solar system and outside of it. So what's your take on what you just said about music versus natural sounds?
Well, sound, natural sound, is a social phenomenon. When you talk to me and I talk back to you, what we're doing is we are setting up a waveform that travels through the air. And that waveform, in waves in the sea, here's how a waveform forms. You're an individual molecule of water, and you rise and then you fall, and then you rise and then you fall again. When you rise, you participate in being the peak of a wave. When you fall, you participate in becoming the trough of that wave. But that wave, I mean, now imagine yourself, you're taking a plane from London back to New York, and you look out at the ocean underneath you, and you see a corduroy of waves on the ocean. And you know that you can watch one wave, and it will retain its identity for the whole 700-mile trip across the Atlantic to the shores of Maine. And you know that if you stood on a rock on the seashore, and a wave crashed over you, and you couldn't retain your footing, it would smash you to pieces. It has a force and an identity all of its own, but it's never the same pile of matter twice. It is a social gathering and then relaxation of atoms that, or molecules, that makes it stand up and then makes it fall. But those molecules of water stay in place. They don't travel with the wave. The wave is this traveling something which is constantly recruiting new participants and then throwing them away. So waves are very strange stuff, and waves are part of the elemental sociality of the cosmos. For more on this, you can read my book, The God Problem, How a Godless Cosmos Creates. You and I wouldn't be here if it weren't for the fact that this universe is profoundly communicative. Remember, quarks talk to each other with attraction and repulsion cues. And if it weren't profoundly social, and if every form of sociality that the cosmos conceives leads to something larger and something surprising, the way that putting three quarks together did not just result in three quarks. It resulted in something astonishing that had never existed before, the properties we call a neutron and a proton.
This would be a good time to actually introduce a very interesting concept, something I believe you even wrote a paper, and you can correct me on that part if I'm wrong. Space saving Earth, how space can save Earth. Can you tell us about
exactly.
How did you arrive to that, and what's the basis of the paper that you wrote?
Well, here's the deal. I mean, I wanted to be able to reach somebody like Ocasio-Cortez or Bernie Sanders.
Yes.
Now, you remember, I'm a Democrat, and Bernie Sanders' platform makes an awful lot of sense to me. I do not like his Jews make the best anti-Semites, and he's Jewish. I do not like his anti-Semitism and his posture on Israel at all. But I want to be able to reach him. And in one of his letters, Bernie Sanders said that space is a waste of time and money. We got to solve the problems down here on Earth. Bernie, you're crazy. Right now, we are blowing the tops off of mountains, leveling them, in order to mine them, in order to get materials we desperately need in order to continue being a human civilization. We don't need to do that if we use space. In space, there are medium-sized asteroids that are carrying $1 trillion worth of the same stuff that we blow mountain tops off of, or the tops off of mountains, to get at. And we can get at them there with no environmental footprint, with no danger to what we call nature. Now, nature is life. Nature got started on this planet a little bit less than 4 billion years ago, and it was an extremely iffy proposition. And again, if you had been the visionary at our coffee table at the beginning of the universe, and you had predicted that macromolecules would get together and they would put together something from which another emergent property as surprising as the property of a neutron or a proton coming from 3 quarks, that something wholly new that the universe had never seen before would come into existence, life, I would have said you were crazy, absolutely crazy. Put a bunch of atoms together, in no matter what social pattern, and what do you get? You get atoms. That's all. I'm wrong. You are right. And we get life. Now, life was tenacious, persistent, and imperialistic. It was extraordinarily ambitious. It had to go from being less than, imagine just taking one of your fingernails. It is less than the matter in your fingernail, the initial life. And life has to somehow survive. This is a universe, or this is an Earth, a planet that has been through, or would eventually go through 142 mass extinctions. Why? Because this Earth is the planet of climate catastrophe. What do I mean? Well, in the old days, in its beginning, the Earth was rotating every 6 hours. So a day was 3 hours long, and a night was 3 hours long. Now, what happens when you move from day to night? The temperature goes down a minimum of 80 degrees. You go from being bathed in a poisonous substance called radiation, light, to being bathed in something equally despicable and poisonous, darkness. And the planet is on a tilt, so that it goes through 4 major, massive changes of climate every single year. We call them winter, summer, fall, and spring. Yeah. Right. We take these climate catastrophes for granted. Why are we able to take them for granted? Because life had to be tenacious. It had to be a search engine. It had to be constantly seeking out new possibilities and new ways to exist so that it could beat the next climate catastrophe. And it had to be ambitious because if it remained just a fingernail of life, it was going to be extinguished. It had to take over as much dead matter as it could and could kidnap, seduce, and recruit it into the process that we call life. That's what life has been doing for the last 4 billion years on this planet. It has been trying to green and garden the place. Now, if you take a plane this time from New York to L.A., you see a lot of greenery while you're passing over the East Coast states like Pennsylvania. But once you get past those states, you see brown. All you see is brown. Why? Because the process of greening, or the project of greening the planet, of gardening the planet, is still in its infancy. There are still these huge areas of the planet that haven't been gardened and greened. And what is life's ambition? Life's ambition is to kidnap, seduce, and recruit as many dead atoms and molecules as possible and bring them into the process of life, greening and gardening the place. So if life is truly ambitious and really wants to grab hold of as much stuff as it can, much in the spirit of the gravity balls, the ambitious gravity balls that were swallowing everybody else in sight, if that's life's ambition, there are species on this planet that can do things that we can do better than we can do them, that can do research and development, for example. Bacteria do research and development so fast that we have a hard time outpacing them. We are constantly afraid that our antibiotics are going to be ineffective, that bacteria are going to find ways to resist them. And what are those antibiotics, Dr. J? Those antibiotics are only weapons of mass destruction that we stole from other microorganisms. We didn't invent them. Microorganisms invented them because microorganisms gather in huge groups, like giant cities, constantly exchanging information. But groups of 7 trillion in a single bacterial colony. And they are constantly chatting with each other. And they are constantly upgrading themselves. So research and development is not unique to us. What is unique to us when it comes to our role in the life process? We are the only creatures capable of getting life, of getting ecosystems out of this gravity well and beyond our atmosphere to other barren stones in the sky that also are stones of climate catastrophe and disaster like ours, so that life can take hold and recruit even more dead atoms and molecules into the process of life.
We do have two questions from listeners, which I'm going to hold off on a second to stay on this topic briefly about our friends Akasha and Sanders. What would they say, or what are they saying when you talk about the so-called global warming that Miss Cortez is trying to push in this Green New Deal, which she's not only getting slack from the Republicans, but even longtime Democrats like Feinstein are essentially laughing in her face. And personally, this is just my take. I mean, I come from no science background whatsoever. I'm an economic person, you know, from my university, and before that business, and then I went on to law and, of course, dispute resolution. So I can't say that I'm any expert by any means when it comes to this, but my personal take on this is I don't think that we humans are causing such a dramatic or creating so many problems on this planet that we are solely responsible for global warming. Are we contributing to it? Yeah, maybe 1% or 2% or somewhere in that range, but 95%, I think it's just natural changes. Now, you could talk about the ice age, but what about mini ice ages and mini hot times? I personally think
and
that
global
we're going
warming.
through a cycle.
There have been many global warmings.
That's right. Many global warmings and
well,
many
here's
ice
the deal.
ages.
First of all, back to Ocasio-Cortez for a minute, and back to how space can save the Earth. Ocasio-Cortez and those who believe the way that she believes that we are changing the atmosphere because we are injecting or ejecting greenhouse gases in huge amounts, carbon-based gases. The fact is that if we put massive photovoltaic panel farms in space, 5 miles by 5 miles in size, we could harvest the energy of the sun that's going to waste, and most of the energy of the sun is going to waste. It's an almost infinite source of energy. And we can transmit that down to Earth using the same kind of harmless microwaves that your cell phone uses. By doing so, if we use space solar power, and this is a project I worked on with Buzz Aldrin, and I've worked on with the 11th President of India, Dr. APJ Kalam. If we use space solar power, we can get rid of all of the carbon-based fuels that we are using on Earth. And we can do incredible things to minimize our carbon footprint. Now, is Ocasio-Cortez right? Is global warming for real? Well, yes, global warming is for real, but so are ice ages.
Yes,
and global warmings have occurred long before humans were on this planet because, as I've said, this blob of stone that we've been gardening and greening for the last 4 billion years is the home of climate catastrophe. It is the home of massive, catastrophic climate change. And it has been that way from the very beginning. That's why there have been 142 mass extinctions, all before tailpipes and smokestacks were invented. So whether global warming is caused by man is not the relevant question. The relevant question is it a good idea to try to stabilize the climate? Now, we've been working on climate stabilization technologies ever since we stole the first fur coat off of an animal that we killed.
Yes.
And that goes back for approximately 2.5 to 3.2 million years. When we built the first habitations outside of caves, habitations we could construct, where we chose to construct them. And that's at least 17,000 years ago. We built them with mammoth tusks, mammoth ribs, and mammoth hides. They were like big tents for 7 families. Those are climate stabilization technologies, but they're on a small scale. If we really want to stabilize things so that the climate is the way it was in 1650, which seems to be the preferred date of the climate change people, Yes, let's do it, by all means. It's time for us to go bigger scale with our climate stabilization technologies. But we have to acknowledge what we're doing. And we have to know that the technique of merely returning nature to what it was before we polluted it, that's crazy. Because the nature that was before we polluted it is violent, vicious, nasty, and mean. And climate change is the name of her vicious, nasty game. So yes, we have to tame her. And nature loves those. This is one of many Bloomisms. Nature loves those who oppose her most. I mean, every day, Dr. J, when you decide to get out of bed and you put your feet on the floor and you stand up, you are violating one of the most fundamental laws of nature, gravity. And you do it all day long, every time you walk from one location to another. You break nature's pristine, virgin laws. How dare you? Well, nature loves those who break her laws because they are vaulting nature into the next step of invention and change. And nature is an invention addict. She is an innovation addict. And it is up to us to live up to our role as innovators and breakthrough makers because that's what nature wants. I can show you the whole history of the cosmos, and it's breakthrough and innovation and changing of the rules one after the other, from the invention of atoms to the invention of galaxies to the invention of stars to the invention of molecules and the invention of macromolecules and the invention to life. It's breaking the old rules and establishing entirely new ones all the way for 13.7 billion years. Do we want to advance the cause of nature, or do we want to stop the cause of nature? Do we want to hide and stop innovating because we think that's what satisfies nature? Nature is never satisfied. Nature is ambitious, and it's in her own way greedy for the discovery of new things. And we are her discovery engines. So are bacteria. So if we violate that compact with nature, we are giving a big finger. We are saying a big fuck you to nature. And saying a fuck you with innovation is something nature appreciates. Saying a fuck you with attempting to go backwards and stop having any footprint on nature whatsoever, that's not the way nature works. Nature loves new footprints. I mean, let me give you an example. Once upon a time, a bunch of microorganisms made an incredible technological breakthrough. They figured out how to snag stuff that wasn't stuff, that was mere wiggles in the air, and incorporate it as an energy source into life. The mere wiggles in the air are photons. That's light. And they invented photosynthesis. And for 1 billion years, they chugged away using photosynthesis. Now, all creatures take in what they have learned to metabolize. Metabolism is an invention, and it's an ongoing, constantly improving invention. But they take in what they can now metabolize, and they excrete what they can't. And what they can't, to them, is a poison. So bacterial colonies were farting the stuff that they couldn't handle, the stuff that was poisonous to them. Now, what's a few bacterial farts in a big, big planet and a big, big ocean? Nothing. Nothing. One bacterial colony with 7 trillion individuals would fit on your hand and would be so thin you wouldn't even be able to see it. How could its farts possibly affect anything? Well, eventually, those toxic pollutants built up into the atmosphere, built up in the atmosphere. And somewhere 1 billion to 2 billion years after these cyanobacteria invented photosynthesis, there was a major problem: toxic pollution. The poisons they've been farting out had gotten to the point where they were killing off nearly everything on Earth. So some bacteria worked out a new social solution. They found some tiny little bacteria that were capable of metabolizing the poison, of turning the poison into a food, a fuel, an energy source. And they took in those tiny little bacteria as boarders, making a deal with them. Hey, you just keep taking this poison and turning it into pleasures and into food, and I will make sure that I take care of your environment. I will keep you in an environment that is perfect for you. I will take you places that will allow me to feed your environment. Leave it all to me. And that was the origin of what we call the eukaryotic cell, a cell with both a nucleus and a whole bunch of little plastids or plasmids that handle, well, mitochondria, that handle energy production. And what do these mitochondria eat? What do they turn into food and fuel for you and me? The poison in the atmosphere that was killing everything off. Do you know what that poison is called? That toxic pollutant that life was arrogant enough to spoil the atmosphere with? It's called oxygen.
Oh, really? Because I would have thought that you would have said oxygen is the stuff of life because our atmosphere has 20% oxygen, give or take.
Yes, but it didn't. It didn't before these bacteria started manufacturing.
I was just going to say, yes, before the algae came around, wasn't it just all, I don't want to say, I hesitate to say nitrogen, but what was it before oxygen came around?
I'm not sure, but the bottom line is this. Every poison is a pleasure waiting for its moment of discovery. Every toxin is a food and a fuel, just waiting for the invention that will turn it into an energy source. Never forget that when you see poisons. Poisons are only temporary obstacles we haven't found ways to innovate and incorporate as food and fuel.
Before I get to these two questions, which now there's a comment, briefly, I wanted to touch on what you just said, that we've had 142 extinction level events. Other people call them LEE. Can you describe for us what they are? Because, I think of an asteroid hitting us, but clearly you're talking about more than that. All these different swings of the pendulum as far as our atmosphere, such as the ice ages
they've happened roughly every 26.5 million years. The most dramatic were two occasions in which the Earth turned into a snowball, a giant snowball, and the snow and ice was almost a mile thick.
Wow!
Almost a mile thick. Meanwhile, about 155 million years ago, I think it was, the atmosphere was so rich in carbon dioxide, and other greenhouse gases, not produced by us, produced by what we call nature, that the temperature at the South Pole was warm and balmy, and dinosaurs lived there. And here we are screaming that the South Pole is about to crumble, and all the ice is about to disappear,
and the North Pole too. Yeah.
And guess what? That kind of thing, the total melt of the poles, has been going on for a very long time, and it had nothing to do with humans. So if we want an ark, if we want to save all of the creatures and all the species diversity that's alive today and that was alive in 1650 AD, we have to get busy with climate stabilization technologies like crazy.
Well, again, before we get... Oh, you know what? I don't want to keep these people waiting. Okay, let me just go ahead and... First, I'm going to say the comment. This is from HelidiumLabs.com. He says, Aqua Terratron is the most powerful power system designed yet. Do you know what he's talking about?
I have no clue. There's only a hint in the word aqua, and aqua terra means the water and the earth. And beyond that, no clue whatsoever.
He does have a question here. Again, HelidiumLabs.com. Is your guest familiar with making gold from algae in state extraction?
Oh, my God. I mean, it wasn't enough that we had alchemists who killed themselves with mercury for hundreds and hundreds of years, believing that you could make gold from this and you could make gold from that. But no, gold is a certain kind of an atom, and building that atom is not going to take place by, boiling shit in sulfuric acid or something like that. That's a crazy, to me, and maybe I'm being too immodest or something like that, too arrogant in looking down on this question. But it sounds like just pursuing an old dream that turned out to be a total dead end.
You're actually right, and I have seen something within the last few years. It's not from algae, but there is a laboratory in San Diego, California that is producing gold. I don't know from what, and such small quantities. We're talking about literally close to atomic size or bigger than that, molecules. But
right.
The amount of money and I don't know what else it takes to operate the machine for an hour versus how much gold you're going to get. It's a loss. I mean, it just might as well forget about it. But I do know they've been playing with that idea. And
well, there's another gold on the horizon, and it's called water. And here's why it's the gold of the next 50 years. Because with Elon Musk's rockets, reusable rockets, we're about to get into space in a big way in the next 10 years. With his Starship, if that starts flying in 4 to 5 years' time, he's going to change the name of the game. The Starship carries 100 passengers or a huge amount of cargo or a huge amount of fuel, and then when it carries the fuel into space, it becomes a space station for other rockets. What is the fuel that rockets use? It's hydrogen and oxygen. If you can find water outside of planet Earth, away from the Earth's gravity well, getting water from Earth into orbit is incredibly expensive. These days it can cost roughly $10,000 a pound. $10,000 a pound. Now Elon is going to drop that price rapidly to $100 a pound, but that's still very expensive. If you can find water on the moon, hey, it has a very low gravity, and getting stuff off the moon is inexpensive. Getting water off the moon. Water on the moon? Isn't the moon just a big pile of rock? No, it turns out there's water up there.
Interesting. I was hoping you could expand on that, because when I had this Forbes mainstream scientist who is the space contributor and technology contributor for Forbes.com, absolutely without a question said that there is no water on Mars or the moon. It's just a big pile of dust.
Sorry, that's wrong. Absolutely wrong. Through a variety of sophisticated instruments, we and the Indians, India had a satellite that orbited the moon for roughly 3 years, Chandra, and its equipment, and equipment that we've sent up, has demonstrated unequivocally that there is water on the moon, especially concentrated at the poles. Because at the poles you've got these huge craters that never see sunlight, and ice can accumulate. And Mars is just riddled with water. There's water all over the place. There's water 3 feet beneath the surface wherever you go on Mars. And then there are major concentrations in certain locations. So water, because water can be used for breathable oxygen, which is highly valuable if we're putting humans into space, for drinkable water, which is highly valuable if we're putting humans into space, and for liquid oxygen and liquid hydrogen, rocket fuel. So those sources of water on Mars and the moon, they are going to be the gold of the gold rush, the moon rush of the next 50 years.
You actually answered my next question in that answer, Howard. I got to hand it to you, because I was going to ask, with the discovery of water, that changes the game, because since water is composed of hydrogen and oxygen, wouldn't it be possible for us to create breathable air from it? And you just answered that. So let me get to the next guest question that's been waiting for a while. This is from David Lopez. Are waves coherent?
Waves are very coherent. Again, if you're on that airplane flying from London to New York City, you see those waves, and you see just how coherent they are. Who knows better than anybody else how coherent a wave is? A surfer. That's right. Because a surfer goes out, finds a wave, his whole, everything he's doing is predicated on the assumption that the wave is very real. In other words, it has coherence. And he gets on the back of that wave, and he rides that wave into the shore. Now, that is a very peculiar process, Dr. J, because a wave doesn't exist. As I said, a wave is just a bunch of water molecules bobbing up and down and then ceasing to be part of the wave or becoming part of the next wave. A wave has no substance of its own. It is constantly throwing away the substance you just had and ingesting new substance. So in a sense, a wave has no existence, and yet it does, because it is a massive social, I call it a recruitment strategy in my book, The God Problem. The recruitment strategy is some process, like the process that is a wave, that will recruit anything it can find in order to maintain its existence. Memes are a recruitment strategy. We know that. That's easy. But waves are a recruitment strategy.
Here is actually one of my favorite topics, and this is great because this is coming from a listener. This is MacArthur. MacArthur, please forgive me if I mispronounce your last name. Lewis Saint. He says, Dr. J, when will we have space-time metric propulsion and anti-gravity? Clearly, Howard, that's for you.
Well, it is, us thinkers have a big problem. We always extrapolate from what's been happening over the last 10 years, the last 100 years, the last 1,000 years. What we don't take into account is radical, dramatic change. And radical, dramatic change does come along periodically. In roughly 1980, I was working with Shep Gordon's office. Shep Gordon managed Alice Cooper and managed Luther Vandross. I was working on Luther Vandross. And Shep Gordon's main person in New York and I shared a fascination in technology. And there was this brand new thing. It was a suitcase. And you opened the suitcase, and there was this huge thing that was a phone. And you could actually talk without wires to somebody else on another phone. Not a phone like yours, a normal phone. We were fascinated by this thing. If you had predicted back then that was going to end up as a device that was a quarter of an inch thick and had a big screen and full color, was actually a small computer, I would have said you were crazy. But in 2007, the iPhone was introduced, and it's changed everything. And even for those who were able to predict, I mean, we were basically predicting the miniaturization of these things in 1980. But we didn't predict what would be a result of this. I mean, Peter Gabriel and I, in 1979, sat down together, and we brainstormed the home entertainment technology of the future. And I came up with all kinds of crazy ideas that were fascinating to people in the press. And Peter came up with a very simple idea. And his idea was that we were about to have computers. Remember, computers in those days, up until that time, have been the size of a house, a townhouse. And Peter said, we're about to come up with small computers that individuals can own, and we're about to democratize the computer. I mean, only big corporations in the military could afford computers at that point. Well, who was right? Peter was right. But even Peter and I could not predict some of the things that would come out of this computer revolution, and we didn't predict this combination with the internet. We didn't predict Facebook. We didn't predict Google. We didn't predict the World Wide Web. We didn't predict browsers. And all of those things have caused radical change. And we certainly didn't predict commerce on the internet thanks to laptop computers. And putting computers in a phone.
Yes,
we would have known. I mean,
smartphones.
and the idea of putting a camera in a phone, I thought that was so wacky it was ridiculous. It was never going to catch on.
But yet it did.
Yes, it did. So even the best of us prognosticators and futurists, and I'm regarded as a futurist, get it wrong because we can't predict the big, disruptive, incredibly innovative changes. And what did I just tell you that this cosmos is addicted to, that nature is addicted to? Breakthroughs, disruptive change, radical change, unimaginable change. So when we come up with these things, we are doing the work of the cosmos. Think of it this way. We are all children of the Big Bang. If you try to put your left finger through your right palm, it won't go through. Now, here's a question for you. Are you less than 100 years old?
Yes.
Okay. How about the stuff that kept your finger from going through your palm? Is that part of you?
I mean, it's attached to me.
That's right. And you have control over it. And you think of it as part of yourself all the time.
Yes.
Well, guess how old the stuff that kept your finger from going through your palm is?
Millions, tens of millions, hundreds of millions, billions, maybe?
You're getting into the right territory. It's 13.7 billion years old. It came into existence at that first flick, the first 10 to the minus 32nd of a second of the cosmos in that instant when quarks discovered their social nature and gathered in groups of three. It's protons. It's protons. So you are a child of the Big Bang. And if I'm going to tell you the story of your life, and you are a cousin to stones, stars, planets, everything that we consider the environment. You are its cousin. The two of you are married at the hip because you are both children of the Big Bang. And if I'm going to tell you your story, I need to tell you your story from the instant of the Big Bang onto how we are managing to think the thoughts they were thinking as we have this conversation. And in fact, that's the premise for a TV series and a book that will take a while before it comes up. It's called The Grand Unified Theory of Everything in the Universe, including Sex, Violence, and the Human Soul. But that's way off in the future. I mean, right now, my most recent book is How I Accidentally Started the 60s. So,
and we are going to get into that. And actually, you spawned off two ideas that I'd love to ask you about. But before we do, I want to acknowledge the listener, MacArthur, who has another question. I think it's sort of a continuation about the last one. He says, what about, and I hope I say this properly, tachyon particles, T-A-C-H-Y-O-N?
I read about those periodically, and I've never quite entirely understood them. And all we can say is this. Remember, Anton van Leeuwenhoek, by turning his microscope down on pond water, discovered that there was a whole world around us and within us that we had never, ever imagined or perceived. And when Maxwell, I think it was, put a piece of paper over a magnet and sprinkled iron filings on it, he discovered there was another invisible stuff that we had never imagined before, a magnetic field. So there are all kinds of things far beyond our imaginings that even a person who, look, I do knowledge 24/7. I even have podcasts going on, science podcasts or the news, when I'm sleeping because I just can't stop taking in new information. And despite the fact that I'm doing that, there's so much I don't know. The more you know, the more you know you don't know, and the more ignorant you feel. On the other hand, the more you think you know everything, the more ignorant you are.
The imposter syndrome. I've heard a Caltech scientist actually label that as the imposter syndrome, which it essentially is exactly what you just said, Mr. Bloom. The more you know about something, the more estranged you become, meaning that there are more questions you ask. So you may start at a level where, like, I don't know anything about this subject, so let me start reading about it as much as I can. But then all of a sudden, you have more questions than you started with. So it just absolutely fits, and I could say the same thing with everything I've been learning all my life. The more I got to what other people would say is knowledgeable, the more I started to feel, well, hold on a second. I think I have more questions than answers than I used to have.
Right. Well, you can measure a person's intelligence by the amount of stuff he knows he doesn't know.
True. Very true. Now, you mentioned the Big Bang, and this is where my two questions come in. First, let's talk about the Big Bang. I've heard theories that the Big Bang wasn't just a single event, that we are not living in a universe, that we are living in this multiverse with different dimensions, and the Big Bang is something that's been going on for infinity and is still going on. I mean, just according to this theory, from the time we've been on the show, there's been a Big Bang happening every millisecond, and the amount that have happened in the last little over an hour are, again, almost endless. Have you heard that theory before?
Oh, yes. It's called the multiverse theory. It's very popular. I really am a skeptic about it. But when you were a kid, did you ever put vinegar on baking soda?
Yes.
In order to make an artificial volcano or in order to power a little submarine or something like that. Well, remember how the bubbles just kept coming forth?
Yes.
The multiverse theory is that universes are bubbling forth like that. And beyond that, it goes, the multiverse takes advantage of the currently fashionable quantum theory, which says that a particle can be in many states simultaneously until it is perceived. And then once it's perceived, it collapses down to just one state. Well, when I'm saying this sentence, according to multiverse theory, and my mind thinks of saying it differently, but I choose not to use that other option. In another universe, bubbling forth at the second, that other option is being performed, is the reality. In another universe, I'm saying the thing that I decided not to say when talking to you. There isn't much evidence for it. It's entirely based on mathematics. Sometimes mathematics is incredibly, cannily right. And sometimes mathematics just isn't right at all. So we have yet to see. I mean, I have a theory. I'll give you more of my scientific credentials. So I got into microbiology and theoretical physics because of Anton van Leeuwenhoek and Galileo when I was 10. By the time I was 12, I had co-designed my first computer, and it won science fair awards. I had built my first Boolean algebra machine. That's symbolic logic, and it's a form of symbolic logic that was used in search engines until recently. The ands or ors that you put in capital letters if you wanted to get advanced in your search, those are Boolean terms. And I had been schlepped off to a meeting with the head of the graduate physics department at the University of Buffalo, and I'm sure my mom had twisted all kinds of arms to get me this audience, and I'm sure that this guy had set aside 5 minutes for me, because what head of a graduate physics department wants to talk to a 12-year-old? That's insane.
That's true. Unless you're a genius, certified genius.
Well, my mom must have read every magazine in that guy's waiting room, because we didn't come out for over an hour. We were discussing the hottest science topic of the day. It was 1954 when I was 12, and the big controversy was over steady-state theory versus Big Bang theory. And Fred Hoyle, who was the guy behind steady-state theory, who was brilliant and made major contributions to science, was absolutely sure that was the year he was going to destroy Big Bang theory and the world would never hear of it again. He was about to defeat George Gamow, the Russian living in America, who was the major proponent of Big Bang theory. So we sat there, the head of the graduate physics department at the University of Buffalo, my hometown, and I, discussing the interpretation of the Doppler shift and what its implications are for Big Bang theory versus steady-state theory. And it was the hottest topic in science at the time. So my guess is that's why he didn't want to let me out of his office. And when we finally got out, he stood above me and he put his left hand on my right shoulder, and he said to my mom, "You don't have to save for grad school for him. He'll get fellowships in theoretical physics at any university in the United States he wants." So, and when I was 16, I was working at the world's largest cancer research center as a really incompetent lab assistant. But during lunch hours, I gathered this group of kids much older than I was and the scientists who had been put over me to make sure I didn't break too many test tubes. And I was trying to solve something called the PTE problem, the charge, or CPT problem, the charge, parity, and time problem, which basically is this. If matter and antimatter are created in equal amounts at the same time, where's all the antimatter? And by the end of the summer, I had fashioned a theory of the beginning, middle, and end of the universe. It's the Bloom-toroidal model, otherwise known as the Big Bagel, that not only explained where the dark energy might be going, or the antimatter, might be going, it also predicted something that would be discovered 38 years later, and we call it dark energy. So if you go online and you look up Howard Bloom Big Bang on YouTube, you will see a 5-minute animation of this theory, and it is the only theory out there that makes sense out of what dark energy is. So that's my scientific base. And then you might be wondering, well, first of all, how I accidentally started the 60s.
Yes.
because that's, oh God, I didn't pull up the quotes on that. Timothy Leary said that it was a monumental masterpiece of American literature, was filled with nonstop waves of hilarity, scientific comedy routines, and he compared it to James Joyce, and he ended with wow, woo, aha. And there's a story behind how Timothy Leary came up with that quote. Well, there's a story behind the book. When I was, first of all, I was a science nerd. And at the age of 12, I realized I was an atheist. And at the age of 13, when my parents were trying to drag me to high holiday services, I refused to go. But they managed to get me into a suit somehow, and they got me into the car, but I wouldn't leave the car to go to the synagogue. And they were literally pulling at my ankles while I held onto the door frame, nice sturdy American workmanship. It was a Fraser, a blue Fraser. And while they were tugging at my ankles, this is what occurred to me. Galileo's contribution was taking the spyglass and turning it up. Anton von Leeuwenhoek's contribution was taking the lens with which he looked at fabric and turning it down. I was an atheist. Therefore, there are no gods in the heaven, there are no gods in the earth. But right now, gods are very important in this scene of my parents trying to shred my socks and get me to the synagogue. Where are the gods? the gods are inside of us. So my job became to turn the lens inside and look for the gods inside. And I became fascinated with ecstatic experiences. The film Black Orpheus came out, and I watched a Macumba ritual in South America. And in a Macumba ritual, there's drumming and there's singing, and eventually somebody goes into what looks like an epileptic fit and ends up on the floor foaming at the mouth for hours. And that person has been seized by God, by Christ, whatever God he believes in. And I wanted to not only experience that ecstatic experience, I wanted to be able to show how that kind of ecstatic experience powers the forces of history. And that became my goal when I was 13 years old, one goal among many. So when I did get fellowships at 4 different grad schools. The head of the graduate physics department had been right, and I got magna cum laude and Phi Beta Kappa and all of that stuff. And I suddenly realized that graduate school is going to be Auschwitz for the mind. They're going to kill my interest in the ecstatic crowd experience that powers the forces of history. And this is something I really need to explore. I cannot explore it by giving a paper and pencil test to 22 college students in exchange for a psychology credit. How much mass of what Emil Durkheim, the founder of modern sociology, calls collective effervescence? How much collective effervescence is there in 22 college students filling out a paper and pencil test? So I jumped ship, and I went into a field I knew absolutely nothing about. Why? Other kids hadn't wanted me around. And other kids, the pop culture was the culture of the kids who threw me out or chased me around the block or beat me up. But I dove into pop culture about which I knew absolutely nothing. And remember, I am interested in mass behavior, from the mass behavior of quarks to the mass behavior of human beings. And I was on a quest to find the gods inside and how they affect the forces of history. So I ended up founding the biggest PR firm in the music industry. See if you've heard of any of these clients, because it was the 1970s and the 1980s, and that's a long time ago, okay? Brace yourself. Michael Jackson, Prince, Bob Marley, Bette Midler, Aerosmith, Kiss, Queen, Run DMC, AC/DC, Billy Joel, Billy Idol, Paul Simon, Peter Gabriel, Joan Jett, ZZ Top, Grandmaster Flash and the Furious Five, and a bunch of others, Kool and the Gang. It just goes on and on and on.
All of the above. That's what I've heard of. All of the above.
And my role, really, yes, I put together the best PR firm in the music industry. That's why we literally reinvented PR in the music industry. And when Billboard came out with the Billboard Guide to Music Publicity, which was a college textbook, there were something like this. There were 20 pages of nothing but interviewing me on what I call perceptual engineering, which was the technique that I worked on, that I created. So I became a legend in that field. But what was I really after? I was really after the ecstatic experience, and I kept finding out more and more about it, because I had my first ecstatic experience when I was 16 years old, and I was very unpopular in my high school, but they kept electing me the head of something called the program committee. So I oversaw 4 program assemblies, or 5 program assemblies a week, and I emceed 5 of them, and I programmed 2 of them. So the juniors came to me, and they said, we're having a dance, could you advertise it? And they didn't realize the irony of the situation. I was incredibly unpopular. If there was a dance anywhere in Buffalo, New York, the organizers and the kids at the dance wanted me as far away from Buffalo as possible, preferably Cleveland or the Moon. And yet they were asking me to advertise a dance. So I put a piece of music on a turntable, and I did something I had never done before. My parents tried to send me to dance class for a year to try to make me normal, and it didn't work. I couldn't dance, and I danced. And it wasn't the box step, it wasn't the foxtrot, it wasn't anything you've ever seen before. It was like a Looney Tune on LSD. And I saw the faces of the 350 kids that hated my guts melt. And I saw their pupils dilate, and I had an out-of-body experience. I was on the ceiling watching this happen. I saw as their collective force, the crowd's force, came together like a giant amoeba, and that amoeba reached out a pseudopod to me, and that pseudopod became a pipe through which energy flowed through me to something, I don't know, in my head, maybe, above my head, that utterly transmogrified that energy and sent it back coursing out through me in a continuous feedback loop. And I watched this whole thing from the ceiling. And when I was finished, the kids did something they had never done before in my time in that high school, and they never did again, not for football heroes, not for anybody. They crowded down to the foot of the stage as if they had rehearsed this move all their lives. They picked me up off the stage, they carried me out of the auditorium, and they carried me up to the building above in which we had our classes. Now, if this isn't the crowd phenomena that I have been looking for since the age of 13, that mass passion, that collective effervescence, that is the forces of history, then nothing was. And I found more and more and more of that in the music world, in the rock and roll world, because performers go through the same thing I had gone through. Prince went through the same thing I had been through. John Mellencamp was so seized by a force greater than himself, so much seized by that collective feedback loop that you become a part of, that you become the pipe for, that when he came off stage, he would look as if he had no eyeballs. He would look, his eye sockets would be big, hollow caves, and his personality would be gone, and he would be like a straw man, a stuffed man, a tin man, not a human. And he would have to be led to his room, and then he had a room off of the dressing room where he sat in private for an hour. And he once let me sit there with him, or he sat there with his wife, Vicki, because it took an hour for his personality to come back. And John found that one of the most painful experiences in the world. And he swore time after time after time that he would never tour again because he didn't want to have to go through the wrenching of that experience. Peter Townsend explained it, the founder of The Who. Peter Townsend and George Harrison of the Beatles were trying to get Eric Clapton off of heroin.
I didn't know that. I know he was.
Yes.
He talked about cocaine, so I figured that was the drug. I didn't know he
well,
was
heroin was the
junkie.
drug. Was one of the drugs back then too. And George Harrison wrote a song about it. It's the one that goes Montelli Mort, and it's got a whole bunch of delicious sounding nonsense words, which all happen to be the names of chocolate in a mixed chocolate box. And why was he singing that? Because when he was stoned, Eric Clapton was eating candy, lots of it. Well, so these guys wanted to get Eric off of the drug. And Peter Townsend sat Eric down and said, look, I know why you are using heroin. You go on a stage in front of 17,000 people. You feel the souls of those people come together. You feel that mass soul, that group soul, coming through the stage and coming through you. You become a pipe. That energy goes to the Godhead. The Godhead is what transmogrifies it. And you are a pipe for the Godhead. So for an hour and 10 minutes, you are a pipe for 17,000 human souls and for the Godhood itself. And when you walk off stage, that pipe is empty. And it aches. And you hurt. And you fill that pipe with heroin. Well, that's one of the best descriptions of what I had gone through at the age of 16, what I saw John Mellencamp going through, what I saw Prince going through, that I've ever seen. And so where was I, Dr. J? By evading grad school and by going into something that there's no room for in the academic world, pop culture, and going for the mass passions at the very heart of pop culture, trying to understand it as a scientist, doing what my friend Robin Fox, who is the founder of the anthropology department at Rutgers University, he calls it participant observer science, where you participate with all your heart, all your soul, all your empathy, everything you have in the phenomena in order to understand it. I was in the very land where the gods come to life most vividly. So I was lucky as a science person to have access to something. How many science people have access to somebody like Michael Jackson or Prince?
And
how many
I would
how many
say
of them,
none, really.
And how many of them can take a 19-year-old like Prince that nobody's ever heard of and build his career over the course of the next 4 to 5 years? I was with him for 7 years.
Into a global superstar.
Yes, exactly. Now, is there anything in common between building a global superstar and the Battle of the Gravity Balls and the Great Gravity Crusades?
No.
Yes,
I don't see it.
Everything in the world. Gravity balls work to have influence. The more they can accumulate smaller gravity balls, the greater their influence is, their gravitational influence. And you build a person like Prince who deserves to be a star because he eats, lives, and breathes music. You cannot stop him from making music. He deserves to be a star. And you build him, and you build him, and you build him. So you're building his social magnetism or his social gravity until finally his social gravity is so great that like a star itself exploding from dead matter into a nuclear furnace, Prince explodes.
We have a few questions from the listeners, but before I get to them, I want to get your, opinion on string theory. What do you think of it? And briefly, if you could, in a one-liner for those who are not as familiar with it as I am, if you could briefly explain it and give your thoughts before we jump to these other questions, since we do got about 20 minutes left.
Okay, string theory is that basically the entire cosmos is composed of little tiny strings so small that they would look microscopic even to an atom.
Subatomic.
Yes, and those strings vibrate and produce certain harmonies, we'll call them, for lack of a better term. And the way the string vibrates determines its properties and determines whether it's going to be a participant in an electron, a neutron, a proton, or whatever. And it's a beautiful theory mathematically, and it involves using math that goes into, that settles into either 6 or 11 dimensions. And it could unify a great many theories, and that's what we've been looking for, grand unified theories, for a long time.
Einstein was working on that, right?
Yes, Einstein was working on that. I've been working on that my whole life. And it's just been a goal for a very long time. When Newton looked at the work of Galileo and looked at the fact that Galileo had discovered that the star, at least the planets, are just rocks, big rocks, he put that together with the idea of gravity. And he put it together with the idea, and remember the apple that fell on his head, that's gravity. And he thought, okay, maybe gravity is universal. And maybe it doesn't just apply here on Earth. Maybe it applies in the heavens. And maybe it applies to those big gravity balls, to those stones in the sky that we call planets and moons. And then he worked out the math of how you could have steadily counterbalancing force of gravity and force of it's not circumpetal. Well, the locomotion that you get when you swing a ball on a string above your head and you feel the force, the faster you spin it, and centrifugal force. So he worked out how the balance between centrifugal force and gravity could explain the orbits of moons and planets. It was brilliant, and it was a grand unifying theory because it took the apple that probably was apocryphal. It probably didn't fall. I mean, certainly apples fall, but he probably imagined it rather than having one fall on his head, but took the gravity that impels an apple to speed toward Earth with the gravity that holds a planet or a moon in its place. It was a grand unifying theory that pinned the minor stuff that happens on this planet to the stuff happening in the heavens. And we've been looking for grand unified theories of that kind that pull a whole bunch of unlikely stuff together for a very long time. And yes, Einstein was working on that. And in fact, his theory of relativity has just held up and held up and held up and has turned out to be a grand unifier in ways that Einstein himself never imagined. For example, there was a guy who was an artillerymen have mathematicians. You have to have a mathematician with you if you're in artillery because he computes the trajectory of whatever it is that you're firing so that you fire it at exactly the right angle to hit your target. And one of those mathematicians figured out, I'm trying to think of his name, but he figured out that one of the implications of Einstein's math was that you would get certain gravitational centers so strong that they would swallow everything, including light. So you wouldn't be able to see them because they were swallowing their own light. But both he and Einstein thought these were mathematical fantasies, that they could not and would not exist in the real world. Well, you and I both know they exist. They're called black holes.
Yes.
But they were predicted by Einstein's math. So Einstein pinned together, and this didn't happen. We didn't find that there were real dark black holes until after Einstein was dead. But it turned out that Einstein's theory was a unifier of a kind that even he didn't imagine. So we are constantly looking for grand unified theories, but my emphasis in my grand unified theory is to put together the behavior of the Big Bang and theoretical physics with the behavior of human beings and the forces of history, and ecstatic experiences too.
Now I'm going to go to the questions, and I'm going to go in reverse order because this most recent question is about string theory. Can string theory be used to cure cancer and other diseases?
Only if you're a charlatan. First, string theory, we haven't found any way of proving it, and it could work out to be 300 different theories, depending on which string theory approach you choose. So as of now, string theory has no relationship to the real world in which you and I live. It would have to go to the point where it was proven to have a relationship to the real world in which you and I live, and then it would take people like me who are willing to be synthesizers and go way outside the bounds of the normal in order to bring things into science that are genuine mysteries that science should be regarding, because the obligation of science is to see the questions in everything, and then to answer those questions. It would take people who are synthesizers to turn string theory to the purpose of doing something useful for cancer. It could take 60 years, or there could be some blinding invention. I mean, there's a scientist named Gilbert Ling, and Gilbert Ling came up with a theory of the ways that cell membranes work. And it was not the fashionable theory of the time. He had been a very respectable scientist, and people who had the opposite theory threw him out of science entirely. Well, a guy named something like John Demoutian came up with a device based on Ling's discredited theory, and it's called the MRI machine. Now, do MRI machines actually work? You bet.
Yeah,
but the invention of the MRI machine, was based on a theory that the world of legitimate science had discarded as phony. And Gilbert Ling, in his 90s, is still alive today, I believe. I last heard word on his life 2 years ago. I hope he's still alive. But he had to go through, science is a brutal process. It's a social game. And it's a social game that follows the rules of the gravity balls, the great gravity crusades. He who is big becomes bigger. He who is small is swallowed. And that's the way it works in science. It's one social clique, one subculture up against another subculture. And each subculture has its own chosen hypothesis. And the subculture that wins the battle gets to make its hypothesis universal. And that's what's happened with the current theory of global warming, which has a big mistake. It assumes that nature, that we can return nature to an equilibrium. Nature hates equilibrium. Nature despises equilibrium. Nature is into the stuff that the surfer on the back of the wave has to tame. And that is, it does outrageous things, and then it tames them, and it turns them into energy sources. Nature is not nice, but nature has ways of taking all of her violence and harvesting it for some greater, not good, but for some greater creative disruption.
Now, this is a question with another listener who wrote a comment, possibly the answer to the question, so I'm just going to read both in case you want to comment on the other listener. Okay, it says, what about the holographic med pods that can regenerate limbs and reverse cancer? And then the listener has the answer or comment, says, quantum med pods have been converted to quantum images to your phone, and that image becomes a transducer to water that implodes cancer. How would you handle that, Howard?
Look, I'm not an expert on everything. I try to be an expert on everything. I try to be an omnologist, and omnology is the aspiration to omniscience, which is basically the underlying aspiration of science. So there are many things I don't know. And I can tell you that if this worked, first of all, it's not possible given current technologies. And I follow changes in technology actually minute by minute. It's just not possible given current technologies. It is unfortunately at this point a fantasy. However, fantasies can be materialized as realities by people who are willing to persist hard enough in turning them into realities. Not all fantasies can be turned into realities, but with persistence, and especially multi-generational persistence, let me explain that. Once upon a time, Greeks came up with the myth of Daedalus. Daedalus wanted to get off an island in which he'd been imprisoned, and he had his son with him. And so he figured out how to build wings out of wax and feathers. And he built this wax and feather concoction or contraption for his son Icarus. But it was made of wax and feathers. And his son Icarus was so exhilarated by his ability to fly that he flew too close to the sun and the wax melted. Well, that's the first instance I know of humans dreaming of flight, and that's approximately 800 BC. Well, we worked and worked and worked on turning that fantasy into a reality. 1,900 years later, almost 2,000 years later, Leonardo da Vinci was drawing one flying machine after another, and still we could not fly. And if his mother had walked into the room, she would have said, "Leonardo, would you stop wasting your time on that stuff? It's never going to happen." And she would have been right, up to a point. We just kept on working on these things. And then in the 1800s, a guy named George Cayley came up with an idea of a vertical stabilizer for gliders. But still, by the time he died, there was no such thing as flight. It was still a ridiculous fantasy. And then a guy named Otto Lilienthal built functioning gliders and flew on them off of a hill, taking careful notes on every single flight to see how the camber of the wings affected the flight, until he finally died on something like his 1,000th flight. Well, but that was the best he could achieve. But that was so close to the dreams of Daedalus and Leonardo da Vinci that it was ridiculous. This guy was actually flying. And two bicycle makers in Ohio, the Wright brothers, of all places, picked up Lilienthal's book, chronicling every single flight and what influenced the flight, especially the camber of the wings. And they came up with the first actual flying machine. That's multi-generational persistence. So when you come up with a crazy dream, like a quantum machine that can somehow cure cancer, well, you might be right about the quantum, it might be something else. But yes, a machine that will cure cancer, it's crazy right now. It doesn't exist right now. But does that mean it will never exist? If we are sufficiently persistent, and not just persistent in our individual lives, but persistent over the course of many generations, there are so many things we can make happen that it's ridiculous. And does nature like that? Nature loves those who oppose her most.
Because
nature loves her innovators.
Yeah, and almost like you said, radical change, of course.
Right.
Because we have 10 minutes left, I'm going to merge these two questions together, and I believe they are still on the topic that we were talking about. The first one being, can frequencies regenerate organs? And the other part is, if frequencies can kill cancer cells, how it can regenerate organs like the lungs and kidneys?
Well, killing things is easy. Building things is hard. So regenerating limbs, that's a problem we've been working on. But we are 30 years away from coming up with a solution, maybe 50 years away from coming up with a solution, but we're working on it. We're trying to figure out how in the world, well, if you ever had an Anolis lizard, one of those little lizards that they sell at the pet store, and you've held on to its tail, and it's been really, really insistent on getting away, you end up with a tail in your hand, and the lizard is running off doing what he wants.
Yeah, because the tail will regenerate, right?
The tail will regenerate, exactly. So we're looking at regenerative capacities in nature, and they do exist. I mean, one thing that, what was his name, Dreich, studied was how you took I think it was a sea cucumber or something of the sort, and as it was beginning to develop and cells were multiplying, you took one tiny little piece of it, and it would start from zero and start generating a whole new organism. Well, we've been studying that kind of thing in a scientific manner for roughly 100 years now. And will we learn from it well enough to be able to regenerate limbs? We certainly hope so, but we're not there yet.
Okay, based on what else I am reading here, I think we covered the questions so far. The rest are comments and other people sort of commenting on what you said, as well as people also trying to answer other listener questions. Now, let me go back to certain things you've written. Manifestos, you call them. I call them papers, published papers. Or one of them I wanted to ask you about is Garden the Solar System, Green the Galaxy. Talk about that and
well, I'm involved in the space movement. When I was 11 years old, I used to carry around an engineering manual in my right-hand pocket that gave the liftoff velocities for rockets that would make it to something that had never been achieved at that point, orbit. I was 11. It was 1954, and we wouldn't achieve orbit until 1957. And it wasn't us who would achieve orbit; it was the Russians. So I've been heavily into space ever since I was a kid. And a bunch of people in the space community, people from NASA, the National Science Foundation, and the National Space Society, kidnapped me in 2005 and persuaded me to go to a space conference. Now I'm on the board of the National Space Society. So what was the question again?
I was asking about you call it manifesto.
Oh, yeah, so what I have seen ever since the days of Chesley Bonestell. Chesley Bonestell was a guy who did set designs. Look, the Nazis were the only ones to put the money into a really big rocket program. And they gave that money to Wernher von Braun and a bunch of his fellow scientists that he had organized. Wernher von Braun and Willy Ley had been part of something in the 1920s called the German Rocket Club. And in a rocket club, you're able to cadge enough money out of your parents to make a rocket approximately the thickness of your forearm, or maybe your upper arm. And that's about it. But something happened in 1933. There was a massive political change in Germany. And all of a sudden, Wernher von Braun got a very big budget from a guy who wanted futuristic weapons and thought the rockets might do the trick. So Wernher von Braun eventually ended up coming to the United States with most of his rocket team. And in roughly 1945 to 1948, Wernher von Braun and Willy Ley, a friend from the German Rocket Club, found this guy who was doing set designs in Hollywood, and he was also designing the facades of buildings. He designed the facade of the Chrysler Building. Look it up on Google Image. It's amazing, absolutely astonishing. But in his private time, he did what he really wanted to do, which was space painting. So the three of them got together. Chesley Bonestell was the name of the illustrator, and they did this series of incredible illustrations of what a space program might someday be. We didn't have a space program. It was a crazy idea, like flying had been in the age of Daedalus. And the pictures were wonderful, but they had a problem. And space artists had that problem ever since. It was all tin cans. It was all humans living in tin cans. Tom Wolfe came up with the phrase, spam in a can. And tin cans are not what humans like to live in. Now, we talked about the ambition of life to kidnap, seduce, and recruit every dead atom I could find. I mean, imagine how many dead atoms there are waiting to be kidnapped, seduced, and recruited in the moon. It's an astonishing number. None of these pictures had us taking ecosystems to space. And the fact is twofold. First, you put a human into space, you put up an ecosystem. Because, Dr. J, you are 100 trillion cells. But 90 trillion of those cells don't even claim to be you. They're bacterial colonies, the kind I referred to before, that have 7 trillion individual members in one colony, which is more than all the humans who have ever lived. And they're all over you. They're on your skin. They're producing body odors for good and for evil. They are in your throat, garrisoning your throat against microbial, bacterial invaders. They're in your gut, taking the food that you think you can eat, but you can't. You can't digest it. And they're turning it into vitamin B, vitamin K, and glucose, which is fuel for you, because these foods are not things you can eat, but they can digest them, these bacteria in your gut, and what they excrete is sheer joy for you. It's glucose. It's stuff your body loves more than anything else except alcohol. Those are the two really most quickly converted fuels, convertible to energy in the body. So you are a walking ecosystem. So am I. Those bacteria in your gut are called your biome. So put one of us in orbit, and you've got an ecosystem. But you need an ecosystem bigger than that. Again, our obligation is to take life to the moons and the planets and let it chew on them the way that it's been chewing on this barren, ugly ball of an Earth and turning it into something beautiful. So garden the solar system, green the galaxy in 100 pictures and approximately 2,400 words gets you to utterly reconceive the relationship between man, nature, life, and space, and shows you how we are going to get to space step by step, including Elon Musk's rockets and all the other things that we're going to need, and how we're going to eventually take a big, barren ball that's slightly red and turn it into something that's slightly green. And it's called Mars. Yes.
We have just a couple minutes left, Mr. Bloom, and I wanted to give you the floor to talk about anything you want. And before we finish, I want you to plug in anything you want. But real quick, let me just ask you about Mars, and if you could answer as quickly as you can. Do you think we're on the verge of terraforming it, especially if Elon Musk has the ability to bring that many people and to also bring water without it being so expensive? And then, like you also mentioned, once we get there and if we stop at the moon on the way, well, then you're able to take more water and convert it into breathable air.
Right. Plus, there's water all over the place on Mars. We're not on the verge of terraforming it. We have ideas for it. John Strickland, who's the chief analyst for the Space Development Steering Committee, the group that I run, has brilliant ideas of how to terraform Mars. He's written 2 whole books. I mean, this big, giant 2-volume book about it. But we are on the verge of putting towns on Mars. For those of you who right now are 16 years old or 18 years old or 20 years old, you will see towns on Mars in the beginning of the first Martian cities as long as we are able to keep Elon Musk alive. He's the only man right now in North America who has a vision and has the persistence to turn that vision from fantasy into a reality, and his vision is focused on putting cities on Mars. And his Starship, 100 people at a time, which should be operational, should start hopping, that is, going up and then coming down to demonstrate that it can land and be reusable the way you've seen other Elon Musk reusable rockets land. That is about to start probably within 4 months. And then the Starship should be flying within roughly 4 years. And it will give us access to Mars and the moon in ways we've never imagined before.
I've always been a huge fan of Elon Musk. When the Cousins brothers of Third Phase of Moon were here, we in fact tried to go watch that SpaceX launch, which kept getting scrubbed. Mr. Bloom, it's been a fascinating interview with you, and clearly the listeners in the chat also say exactly that. This has been a great interview.
Well, that's nice. And remember my book, How I Accidentally Started the 60s. The next time we'll talk about that.
Yeah, that's what I was going to say. Now is the good time for you to plug in all your books, and if you have a website or anything like that you'd like people to go to, by all means.
Well, the website is howardbloom.net. The book is How I Accidentally Started the 60s. Timothy Leary says it's a wow, woo, and ha experience. Next time I'll tell you the story of how that Timothy Leary quote came to be. And that's the book to focus on right now. There are 6 other books. There's The Lucifer Principle, A Scientific Expedition into the Forces of History, which some people call their Bible. Global Brain, The Evolution of Mass Mind from the Big Bang to the 21st Century. The Office of the Secretary of Defense threw a forum based on that book and brought in people from the State Department, the Energy Department, DARPA, IBM, and MIT. The Genius of the Beast, A Radical Revision of Capitalism, which the 11th President of India, Dr. APJ Kalam, says is a visionary book, and after which the Sheikh of Dubai named a racehorse. There's The God Problem, which is a book I'm immensely proud of, and James Burke, the creator of the Connection series for PBS and BBC TV, says it's the greatest cliffhanger of a book he can ever remember reading. And then there's the Muhammad Code. If you are interested in mass behavior, as I am, Islam conquered a territory within roughly 100 years of Muhammad's death, 11 times the size of the conquest of Alexander the Great, 5 times the size of the Roman Empire, and 7 times the size of the United States. That has never been done before. And though the leading historian of imperialism at Harvard says that no empire has ever succeeded in capturing the hearts and minds of the people it conquered, she's dead wrong. Those people who were captured way back then over 1,200 years ago are still loyal, faithful Muslims today, all the way from Indonesia and Malaysia to 8,000 miles away on the coast of the Atlantic in Africa. So if you want to understand mass behavior, this is one thing you must understand. And then how I accidentally started the 60s, which is about how I accidentally helped start the hippie movement in a quest for Zen Buddhist Satori. And I didn't end up with Satori, I ended up with sex. So, but sex is extraordinarily important. It is one of those ecstatic experiences that we have been talking about. So that's it. That's my little list of books. But go get How I Accidentally Started the 60s. Go to howardbloom.net. Let me know what you think of the book.
Howard, you've literally laid out a bunch of amazing topics I'd love to talk to you about next time, including DARPA, as you mentioned, how you started the 60s, the God problem, evolution of capitalism. These are going to be great times when we have you back over and over again. For the listeners, about Michael Aquino last night, just so you know behind the scenes that when Michael Cremo, the forbidden archaeologist, was on, Aquino years ago expressed an interest in doing a show with him, just like he did with Peter Lavenda. And after the show yesterday, he says absolutely yes to Cremo's invitation. So it'll just be a matter of time before the two coordinate together and get on this show. Non-related to guest shows, folks, just the special new YouTube videos that I worked with Third Phase of Moon to get the last one out about these ancient lines that seem to align with ancient ports and even star maps that were found on the big island of Hawaii. If you folks are interested in hearing my near-death experience as well as explaining the psychological phenomenon of why life flashes before your eyes, I can tell it to you from a factual area basis, meaning that I can tell it to you from first-hand experience and not just by quoting some other folks. So pay attention to that. It might be tomorrow, Friday, or just over the weekend, of course, strictly on YouTube. Now, other people need to be thanked. Of course, I want to thank everybody in YouTube Nation, especially for those people who have been participating through the show. You guys have been great, especially for those who asked questions and waited some time for us to ask them. I want to applaud you for being loyal and for being patient. iHeartMedia, we got to throw them a shout out for being one of the big mainstream media that does carry the show, even though we talk about things sometimes that probably upsets the mainstream media. But regardless, iHeartMedia does carry this. All the people in New Orleans, Louisiana, give a shout out to all you at 107.7 FM UPRN and all the affiliates globally, including the one that has followed me through 4 stations over the last several years. That is JC, the owner of Deprogrammed Radio Network in the UK. Also, I want to thank people on my own team. We have Adam, who also goes by Adaraki Studios, as my main moderator. He wasn't here today. We have my assistant producer and VP of Operations, Josh Cherez, and also Pam Brettenberg, who does some behind-the-scenes social media, and also check out her site, UnitedTruthSeekers.com. Remember, folks, the only thing you have to remember about the show is the name of it, Dr. J Radio Live, DRJ Radio Live. The website, drjradiolive.com. Every single social media outlet, from of course what you're seeing on YouTube, to Bit2, which is the cryptocurrency equivalent of YouTube, Mine's the crypto equivalent to Facebook and Instagram and all that, which does pay you folks in Ethereum-based tokens just for using it. Facebook, Twitter, Flickr, Tumblr, Instagram, Google Plus, Gmail, whatever you could think of, folks, it's at DRJ Radio Live. But the number one place you all should be remembering literally is where you're already at on YouTube. With that being said, folks, it is time to officially sign off for the night. Enjoy the next show, and we'll catch you same place, same time this Thursday. And like I said, possibly tomorrow, I will give you that input of my NDE as well as why life flashes before your eyes when you pass away. So now it's time to thank again my listeners and my guest, Mr. Howard Bloom, while I officially sign off.